Hello and welcome to our presentation for the Francesco's mixed-use building.
Hi, I'm Lazel.
Hi, I'm Lara.
Hello, I'm Monica.
I'm May and we are architectdesign.ca.
We started our Capstone journey by presenting our project proposal, which centers on the redevelopment and enhancement of Francesco's mixed-use building. The project aimed to transform the existing structure into a vibrant, sustainable space that integrates commercial activity on the ground floor with a variety of residential units above, promoting community engagement, accessibility, and alignment with current codes and urban planning goals.
Our concept layout focuses on thoughtful urban integration using step-back massing, mixed-use programming, and clear zoning to create a sustainable, community-oriented design with vibrant public spaces and strong connections to the surrounding context.
To take a more real-world approach, we work from an existing set of development drawings provided by an architectural office, taking these earlier documents and carrying out to a contract documents instead of designing ourselves. Our goal would be upholding the design intent set forth by the original architect, and this approach to the Capstone project meant we could have a more technical focus, prioritizing systems and code implementation, and really understanding the software we are using.
One of the most successful outcomes of our project was converting townhouses into live-work units. This allowed us to navigate the zoning restrictions of the 5A Street neighborhood while respecting its character and scale. The live-work concept provided flexible spaces that support both residential and commercial use, offering greater revenue potential for the client. Another key highlight was the integration of a green roof. This transformed an underutilized rooftop into a sustainable functional space that improves energy efficiency, manages stormwater, and reduces the urban heat island effect. It also offers residents a natural area for relaxation and social connection, enhancing livability in a dense urban setting.
Our project is located at 615 17th Avenue Southwest, Calgary, in the evolving community of Cliff Bungalow, just south of the Beltline. Positioned along the active 17th Avenue corridor, the site benefits from both established urban fabric and ongoing development, making it ideal for revitalization. The project covers a parcel area of 28,735 square feet with a proposed direct control zoning. The building features a variety of occupancies with a total GFA of 171,965 square feet and a maximum height of 50 meters. The design aims to contribute meaningfully to the urban streetscape and support the continuing growth of this key inner city corridor. With entrances on both 17th Avenue and 5A Street, the lobby, service access, and retail frontage were carefully positioned to avoid conflicts and maintain a welcoming street presence.
Designing the Francesco mixed-use building was a complex yet rewarding challenge. We paid close attention to the building envelope, selecting materials and systems that balance durability, aesthetics, and energy performance. The exterior of Francesco's features key materials such as aluminum paste composite panel paired with paste brick cladding in red to complement the surrounding architectural character. Curtain wall and window wall assembly enhance energy efficiency and daylight access. These materials were selected not only for their durability and visual contrast, but also to highlight different building elements while maintaining a cohesive overall appearance. The aluminum panels introduce a sleek, contemporary feel, while the red brick adds warmth and connection to the historical context of the 17th Avenue corridor.
Our challenge in the DP set was understanding how the building would stand and be constructed, leading us to develop a structural system that prioritizes stability and efficient load transfer. We use L-shaped strip footings with foundation walls and pad footings supporting a two-way slab system. A shoring wall was added to retain soil and stabilize the excavation. At level 3, a setback created an unbalanced elevation, which we addressed with a transfer slab to redistribute loads. For lateral stability, shear walls were placed near the central core, resisting wind and seismic forces. Above, a flat plate slab system ensured simplicity and effective load distribution, creating a stable and robust structure.
Francesco's is a 16-story mixed-use building with thoughtfully organized occupancies. It includes 2 levels of underground parkade with a total of 96 parking spaces to support both residents and visitors. Levels 1 and 2 feature commercial retail spaces and 6 live work units, with commercial fronting 17th Avenue and live work units oriented along 5A Street, encouraging street-level interaction on both sides. From levels 3 to 16, the tower transitions into residential. A dedicated gym area is located on level 7, offering convenient access to residents. In total, there are 106 one-bedroom units, 73 two-bedroom units, 28 three-bedroom units, and 3 spacious 4-bedroom units. The core layout, which includes both the elevators and 2 exit stairwells, was essential in keeping residential circulation simple and compliant with life safety requirements. By centralizing vertical circulation, we ensured that residents could easily access their units while also maintaining proper egress distances and fire separation throughout the building. The building also incorporates multiple roof areas located on levels 3, 6, 7, 8, 15, 16, and rooftop, with green roofs integrated into levels 8, 15, and 16 to add visual interest to upper-level terraces.
We focus on this detail as it addresses critical aspects of load transfer, waterproofing, and thermal bridging. It ensures both structural integrity and long-term performance of the building envelope. The precast concrete building is sloped away from the building for proper drainage. It's supported by an embedded knife plate welded to an angle plate, which allows for slight movement from temperature changes while maintaining stability. Continuous insulation between the plates minimizes thermal bridging and improves energy efficiency. The slope seal and engineered lumber back dam manage water effectively. The seal directs water away while the back dam acts as a secondary barrier preventing moisture intrusion. An air, vapor, and moisture barrier runs beneath the seal and back dam, forming a continuous protective layer. A seal flashing membrane is installed on the top, and a drip edge flashing redirects water away from the facade. This level of integration is important because it balances structure, performance, and durability in a single high-performance connection.
Another complex detail in the project was the connection between the parapet wall and the curtain wall. This particular junction posed a challenge as there were very few clear references or standard examples available online, making it difficult to visualize and resolve. In this assembly, the sequence begins with the gypsum board finish, which not only defines the interior but also helps conceal the ongoing structure at the top of the parapet. Following that are the steel studs, starting with a 152mm stud as the primary support and a 92mm stud added to reinforce the connection and achieve desired alignment. Between these layers, insulation is installed to address thermal performance. The team believes this setup provides adequate coverage to help prevent thermal bridging across the connection. All of this ties into the curtain wall system, where the mullions became a key visual and structural element. Its placement plays a crucial role in blending the transition between the two systems, creating a clean and seamless finish.
Another detail we provide is the window wall assembly between level 15 and 16. Starting at the exterior, we have triple glazed glass, which provide excellent thermal insulation and sound control. Below it, the spandrel panel consists of floor structure while maintaining the continuous glass facade. Framing the glass are the window wall mullion, which structurally support both the glazing and spandrel panel. Behind the outer layer, there's a combination of mineral wool insulation and an air vapor membrane working together to reduce heat loss and prevent moisture infiltration. The main structure is supported by steel hollow section frame, and in between these members, steel studs are added to support interior finishes. On the inside face, the wall is finished with gypsum board, creating a clean surface while also contributing to fire protection. Overall, this window wall detail delivers thermal performance, durability, and a clean architectural expression, making it an ideal solution for a commercial building envelope.
Another detail that we would like to discuss is the green roof. For the assembly, we incorporated 250 mm of XPS rigid insulation, which provides an effective R value of R50 to meet Calgary's Climate Zone 7A energy efficiency requirements. For the green part, we added drainage, mat, filter fabric, growing medium, and vegetation. In curtain wall construction, anchor channels are embedded in the concrete slab edge. T-bolts slide into these channels, allowing adjustable positioning. Steel brackets are then bolted to the channels, supporting the vertical mullions. This system ensures a secure, load-bearing connection that transfers curtain wall loads to the structural frame. In this roof system, the EPDM membrane serves as the primary waterproofing layer. It wraps the structural tube and extends over curtain wall mullions to maintain waterproofing continuity. This extension prevents water ingress at the transition, accommodates movement, and ensures a durable seal. A metal trim conceals and protects the EPDM, completing the weatherproofing detail. Pavers were incorporated to enhance the roof system's durability, weather resistance, and functionality, offering effective drainage and a smooth walking surface. To keep them firmly positioned, a two-piece metal flashing system was used, fastened to a solid ledger with deck screws.
We wanted to include some interior shots of our building.
Throughout the various phases of this project, we gained valuable knowledge and experience by simulating the role of an architectural technologist. We came to understand just how complex and demanding it can be to develop an accurate and coordinated construction document set, especially for a project of this scale.
One of the biggest challenges we faced this semester was dealing with drawing files in the development permit set that were not properly scaled. This affected the accuracy of our grid layouts and the placement of structural elements such as columns and foundations. To address this, we identified the discrepancies and used Bluebeam to recalibrate the drawings. By referencing known dimensions, we were able to establish accurate measurements and adjust our grid systems accordingly. Once the grids were corrected, we proceed with placing columns and coordinations with the structural layout and began developing the foundation plans with confidence. We believe our greatest achievement this semester was our ability to develop creative and effective solutions to the challenges we encountered, allowing us to produce a comprehensive CD set that successfully captures and delivers the intent of the original design.
Finally, we would like to take this opportunity to thank our mentor, Minto Group, DAAS Architecture, our instructors and classmates, SAIT School of Construction, our families and friends for their support along the way. Without your help and guidance, we will not have been able to achieve this level of progress in our project. Thank you for watching our presentation of Francesco's mixed-use building.